Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 5 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 790, Domino and Tromino Tiling. Let's read the problem statement first. You have two types of tiles, 2 into 1 domino shape and a Tromino shape. You may rotate these shapes. Okay, so domino tile, we can place it like this or we can place it like this. Okay, same way domino tile, uh, we can place it like this or we can place it like this. Okay, right, we can also place it like this and we can also place it like this. Okay, so these are the different ways. Okay, if we rotate these shapes, right, so these are the ways in which we can place these tiles. Okay, these shapes on tiles. Okay, so now after that, given an integer n, we have to return the number of ways to tile n 2 into n word. Okay, since the answer may be very large, we have to return it modulo 10 to the power 9 plus 7. Okay, so 2 into n word, right? 2 into n word. Okay, in a tiling, every square must be covered by a tile. All right, two tilings are different if and only if there are two 4 directionally adjacent cells on the board such that exactly one of the tilings has both squares occupied by a tile. Okay, so this is nothing but the definition of the different tilings. Okay, so let's see that. Okay, so here if I say that my n value is equal to 1, okay, so here you have given an integer n, we have to turn the number of ways to tile n 2 into n word. So here what I'm saying, 2 into 1 word. Okay, 2 into 1 word. So if I draw this 2 into 1 word, so it will be like this, right? 2 into 1 word. Okay, so it will be like this. Okay, so here 2, right, into 1 word. Okay, 2 into 1 word, right? Okay, so now here how many ways? So here there is only one way. If I place the domino tile like this, if I place domino tile like this, only one way, right? Okay, 2 into 1, right? If I place the domino tile like this, so this is the only one way, right? So my output is going to be 1 for this. Okay, now if my n is equal to 2, okay, that simply means my board is going to be 2 into n board. Okay, so 2 into n, so that means 2 into 2 board. Okay, so here this, okay, 2 here and also 2 here. Okay, 2 into 2 board. Okay, so now here how many ways we can place the tiles? Okay, so here let's see the ways. Okay, so let me just copy this. Okay, let me paste the same thing here also. All right, so now see the ways here. Okay, so if I place the domino tiles like this, okay, and here also, right, this is one way, right? And if I place the domino style like this, okay, this is also one way, right? So in total how many ways are there? Two ways. Okay, there is no other way, right? There are only two ways for n is equal to 2. Okay, so 2 is my output. Now let's proceed further. Let's move to n is equal to 3. N is equal to 3. Okay, so for n is equal to 3 simply means 2 into 3 board. Okay, 2 into 3 board. Okay, so my board is going to be look like this, here like this. Okay, it's 2 into 3, right? 2 here and 3 here. Okay, now let me just copy this, okay, first. All right, and paste it here, here, here. Let's paste it here as well. Okay, so now see the number of different ways for n is equal to 3. All right, so one way, if I use this same like verb. Okay, okay, so if I use this, so I can place here. Okay, I can place this here, and here in this empty side I can place one more. Okay, one way. All right, okay, I can this I'm using, right? So all three are vertical here. Okay, all the three dominoes are vertical. Okay, so here also I'm using what, dominoes only. Okay, dominoes only. Here also I'm using dominoes only. Here also I'm using dominoes only. Okay, because this tromino is not possible here. Okay, otherwise one tile will be left out, right? If I use this, so this will be left out. Okay, so that doesn't make any sense. Okay, so I'm using dominoes only. Okay, so now using dominoes only, this is one way. If I use this, so okay, if I use this, so that simply means here. Okay, so here I can place this vertical. Okay, domino only. Okay, using dominoes only I'm making first, right? Now there is one more way now, different tilings. So different tilings, okay, by this definition this is also different. Okay, if I use this here, okay, these two here, all right, and this one vertical here. Okay, because if you see these 4 adjacent cell, there are different ways. Okay, I'm using the different ways of tiling, right? Okay, so both are different ways. So here also I'm using dominus only. Here also I'm using dominus only. Okay, so these 3 ways. Okay, now in these 2 ways I can use Trominos also. Okay, so here I can use this now. This is one way, right? Here also I can use Tromino, right? Like this. So see, all the tiles are covered here. Okay, all right. Now I can use this shape also now here, like this. Also I can use one shape. Okay, this shape Tromino also I can use, and here also I can use this shape. Okay, so if you see, there are total 5 ways here for n is equal to 3, right? So if you see, so these are the 5 ways. Okay, all 3 vertical, this done. Then here these two, see, here your diagram, this one and this one. Okay, this and this, and then this. Okay, this shape. Okay, so they are total 5. Okay, so with n is equal to 3 we have 5. All right, now with n is equal to 4, let's see. Okay, n is equal to 4, let's see how many ways. Okay, all right, so here you see, with n is equal to 1, your output is 1. With n is equal to 2, your output is 2. With n is equal to 3, your output is 5. Okay, so now for n is equal to 4, okay, how many different combinations, okay, different ways of tiling we can form. Okay, so let's see that. Okay, but before proceeding with this n is equal to 4, okay, let's do one thing. Okay, so first let me show you using this Tromino. Okay, before proceeding, so n is equal to 4 means 2 into 4. Okay, so here 2 into 4, so using Trominos. So first let's draw this. Okay, tiling. Okay, so one second. So we are doing tiling in 2 into 4. Okay, 2 into 4, and like this it will look, it's looking good, right? 2 into 4 is right. Yeah, this is right. Okay, 2 into 4. Okay, so now let me just copy this same thing. Okay, copy this, copy it here. There are actually many ways. I think there will be around 11 maybe. Okay, there will be around 11, but I'm not filling all these. Okay, so here I'm just creating this dot dot dot. Okay, there are so many ways for this. Okay, so here I will just show you few ways. Okay, so here, like, if you use this Trominos. Okay, so here if I use the same diagram, right? So this is like this. Okay, here, and you can also use this here. Okay, all right, and also here you can also use this like this here. Here also you can use the same thing. Okay, all right, all right, so this you can use. Okay, and this one also you can use now. You can use like this here, like this. Okay, and here like this you can use. All right, and you can also use this starting from here also. Okay, so actually I'm going to drive one formula now, but here let me show you only few things. Okay, so this is also one way. Okay, so here you can place one vertical, right? Here also you can place one vertical. Here also you can place one vertical. Here also you can place one vertical. Okay, there are few more ways. So like this also it's possible now. Here you place one. Okay, and here also you place like this one domino. So this is also possible. Okay, here you place one. Okay, so this is also possible, right? And let me draw one more only. Okay, I think in total there will be 11. All right, so okay, so here see, this is also 2 into 4, right? So here also you can place like this, one here and one here. Okay, and one here. Okay, so these are the different ways. Okay, is there any other way? You are placing these two like this. Okay, these two like this. Okay, using Trominos I don't think there is any other possibility. So how many we have drawn until here? 1 2 3 4 5 6. Okay, 6 we have drawn, right? And there are so many. Okay, using dominoes also there are so many, right? I think 5 with dominoes maybe. Okay, so let's see. So before that, let's drive one formula. Okay, I want to drive one formula here. So here, let's suppose this is one tiling area, right? This is one tiling area. Okay, now for this tiling area you have to find out the answer. Okay, so let's say for this tiling area you have to find out the answer. Okay, so now here, if I partitioned this tiling area like this, okay, such that the length of this, okay, is nothing but 1, okay, and this you already know, this is always 2, right? This is 1 and this is 2, okay. So now I partition it like this, okay. So here this is n, so definitely this area is going to be n minus 1, okay, right? So now let's suppose there are x ways to tile this area, okay. There are x ways to tile this area, right? And there are y ways to tile this area, okay. So for this I can write like their total number of ways to tile this area is going to be nothing but x into y, right? Total number of ways to tile this complete is nothing but x into y, okay. So see y x into y, okay, one more time. So here you already know that in this part there are x ways of tiling, okay. This is one way of tiling, this is another way of tiling, okay, this is the other way of tiling, this is also another way of tiling, okay. X ways, right? And in this part also you know that there are y number of ways of tiling, okay. So one way, second way, third way, fourth way, fifth way, okay. There are y number of ways of tiling, okay. So here in the first half, if you choose this way of tiling, so with this way of tiling you have these many options, right? You have y number of ways for tiling in the second half. If you choose this way first, so with this way there are again also y number of ways, so that is why x into y, okay. So like from this 2, okay, so in this with n is equal to 2, let's suppose, so you know that there are two ways of tiling, okay. With n is equal to 2, you know that there are two ways of tiling, okay. And now if I want you, like, in this part you already know that there are two ways of tiling, and in this part there is just one domino like this, okay. So now I ask you here, tell me how many number of ways, okay. So here you already know that this is one way, okay. So with this you can combine this, okay, right? With this you can combine this, okay. And also with this you can also combine this, okay, right? So 2 into 1 ways right now, okay. 2 into 1 ways, 2 into 1, total 2 ways, okay. In this part you already know that there are 2, and you in this part you already know that 1. So in total how many ways? 2 into 1, right? 2 into 1, no 2 plus 1, otherwise I will write 3 here, right? But only 2 into 1, because here in this part 2 is fixed, okay. 2 number of ways fixed, and here in this part you already know that 1 is the only possible, right? So here this is always fixed, right, like this. And here you have possibility, you can use like this or you can use like this, okay. So that is nothing but 2 into 1, so that is why 2, okay. I'm not talking about this n is equal to 3, because here you can also use this here and use this here one more, okay. So here see, you are going to say that this is good, here we are adding, and you are also going to say that this is also good, here adding. But here with dominance this is also possible, na? But here I'm not asking this part, I'm also asking only if I add here, okay, in this side one more tile, okay, of this. So 2 into 1, so right, so that is why x into y, okay. So now here I can write this part as f into n, okay, total number of n ways of tiling. So I can also write it like this, f into n minus 1 into this part. Now this part only one domino can be used, okay. One, this is nothing but 2 into 1, okay, only one domino can be used. So here I can write it like this one, okay. And also I can write it like this only, f of n minus 1, okay. There's no use of this 1, okay. F n minus 1 into 1 is nothing but f of n minus 1, okay. So this is done, okay. So now here this f of n, okay, I am forming from f of n minus 1, all right. So now there is also one more way, na, right? So let's suppose this is tiling area, but now instead of here 2 into 1 I'm going to use 2 into 2, okay, 2 into 2. So here then the number of ways to tile this area is going to be f of n minus 2, okay, f of n minus 2. And for this area tell me the number of ways of tiling. So you are going to say that for this part there are total 2, okay, they are total 2, okay. This, or you can say that this is 1 and this is 2, okay, that is why 2, all right. So this is what you are going to say, okay. But here, okay, let's see, let's say your n is equal to 4, n is equal to 4, okay. So n is equal to 4, okay, f is equal to 4, n is equal to 4. So here if you use this n is equal to 2 first, okay, in this f of n minus 2, okay, that's nothing but f of 2, okay, in this part. So in this part you have how many options? You have this as one option, okay, this as one option, and here this is empty right now, okay. And this is one way of tiling here, and here there is one way of tiling like this, okay, this, and this is empty right now, okay. This is for here f of 2, and here 2 into 2. Okay, 2 into 2 part, 2 into 2. Okay, so these are two cases, right? These are two cases. Okay, but now here if you see, if you form this f of 4 using this same f of 3, okay, so here also if you see now, okay, so let's suppose here in this you use this, okay, use this. So you are going to say that here there are also two ways. Okay, there are two ways, this and or this. Okay, these are the two ways here. Okay, this is one way. Okay, for this case only I'm saying, for this case you are going to say when this 2 is fixed, okay, and the remaining twos we are finding out the ways, so you are going to say 2, okay, this or this. Okay, but when you find out this f of n minus 1, okay, so here with this 3 also this is possible now. If you use this one, okay, in this one if you add this one, okay, this, and if in this one is like this, okay, in this also if you add this, okay, so now see these two, this one, okay, see this white colored one, and see this one, adding here 1 and adding here 2, both are same, right? Here in case of n is equal to 2, if you add 2 more vertical dominoes here, or in case of n is equal to 3 also, if you add only one vertical domino, then both are same. Okay, 2 to 4 we are moving, okay, 3 is the intermediate in between, but here they are giving duplicates, right? So here there is only one way. Okay, there is only one way. Okay, I will not consider this way because this way I have already calculated using this f of n minus 1. Okay, so here I can say f of n is equal to f of n minus 1 into 1, okay, plus f of n minus 2. Okay, from 2 I don't want to consider duplicates. Okay, so there is in the this side there is just one way only, there are no two ways, only one way is there. Okay, so here f of n is nothing but f of n minus 1. Okay, okay, so n is equal to 4 and 4 I'm forming. Okay, so with the 3 how many 4s I can form, with the 2 how many 4s I can form, but I don't want to consider duplicates, and with the 1 also how many 4s I can form. Okay, I need to check all this stuff. Okay, so here this is general formula that I'm driving here, f of n minus 1 into 1, so I don't need to write 1 here for this part, and here also I don't need to write 1. Okay, same way here if you write instead of n minus 2, if you use n minus 3, okay, here you use 3 into 2, right? So this is going to be f of n minus 3. So now with this you have to calculate the how many ways. So here also you need to check. Okay, so here with 4, okay, let me tell you what are those 11s. Okay, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6. Okay, and then here same way now, here let me draw, I will not take much time. 7. So here let me draw using dominoes. So first is if you use all verticals. Okay, all verticals. All right, so second case is if you use like this, okay, horizontally, then also all the tiling area is covered. Third case you can say if you use here like this, here you use like this, and here you use like this. And fourth case if you use like this here and here like this. Fourth case if you use like this, and fifth case, sorry, and like this. Okay, so here 6 7 8 9 10 11. Okay, so these are the 11 different base. Okay, so now here what I'm saying for this, okay, so f is equal to 3 into 2 area, so here n minus 3. Okay, so this is going to be n minus 3 and this is 3. Okay, so for 3 into 2, okay, for 3 into 2, okay, so f of 4 only you are forming, but here you are taking f of n minus 3 in this part, and this part is nothing but 3 into 2 now. So with this also you have to check. Okay, so here see using this is a new, right, 3 into 2. Okay, so here in this side 3 into 2 areas there. Okay, so if I draw this 3 into 2, so it is going to look like this. Okay, 3 into 2. Okay, so here in this 2 into 3, or you can say, so here in this if you see we don't want to consider this case. Okay, we don't want to consider this case. Why? Because using this also it is possible. Okay, intermediate. Okay, right, and we cannot use this one as well, right, because using this also we have checked the ways, okay, from this two only, right? And now we can consider the remaining two. Okay, so these two we can consider, right? So here I can say these are the new ones, okay, which we haven't seen in the past. Okay, so using this, right, so these are the two ways here. So here I can say plus of f of n minus 3, and here into this side when there is 3 into 2, 3 into 2, so here I can say two ways. Okay, two ways. Same way, if you derive this formula, you will find out here also f of n minus 4 with 4 also. If you see how many when you are going to use n is equal to 4, okay, okay, with the f here 4 into 2 here, and here is nothing but f of n minus 4. So in this side, if you calculate now 4 into 2, okay, so here you see that what are the new ones. So here, this you have seen in the past now, you have seen this part in the past, okay. So definitely you are not going to use this, okay, uh, the intermediate ones, okay. Same way, you have seen this in the past, you have seen this in the past, you have seen this in the past, okay. All this you have seen this logic in the past, okay. Same way, you didn't see this one, and you didn't see this one in the past, but you have already seen all this in the past, okay, all these different type of ways in the past. So we are not going to use these intermediates ones, right? So we are only going to use these two. So here also you are seeing total two new ways, okay. So here you can also write f of n minus 4 into 2, okay. Same way you will see this pattern, okay, n minus 5 again into 2, only 2, right? So 5 into 2, only 2 are the distinct ones, okay, which we can use. Others we have already seen in the past, like duplicates, right? So why we are reacting duplicates? So here I have shown you now this one and this case, okay, both are similar, right? So if I'm considering this, then I don't have to consider this, okay. That simply means that I have already seen that in past, okay. So here, if you drag this formula, you will get something like this, okay. And here in the end you will something, and value is decrementing now. So in the end you will see something around f of 0 in the end. It will reach here in the end, okay. So now once this is done, okay, once this is done, then after that what you have to do, okay. So if you write this for now again one more time, so this is your formula, right? F of n is equal to f of uh, n minus 1, okay. Then it is nothing but f of n minus 2, then it is nothing but 2 into f of n minus 3, okay. And then it is nothing but 2 into f of n minus 4, then it is nothing but in the end, if you go, it is nothing but 2 of f into 0, okay. So now here do one thing now. Here instead of n, okay, this is your equation 1, and in equation 2 use instead of n, use n minus 1. So f n is going to be n minus 1. So here f of n minus 1, that simply means n minus 2, okay. N minus 1 minus 1, you are placing n minus 1 in place of n, all right. So here n minus 1 minus 2 n minus 3, and here 2 into f of n minus 3 n minus 1 minus 3 n minus 4, okay, this. And here also plus 2 into f of n minus 5, and here until 2 of f into 0, okay. Until here it is done, right? So now here just do one thing, subtract equation 1 and equation 2, okay. F of n minus f of n minus 1, okay. So what you are going to get, f of n minus f of n minus 1 is equal to this f of n minus 1, okay. And here f of n minus 2, and here also it is f of n minus 2, both are going to cancel out, okay. Both are going to cancel out. Here 2 into f of n minus 3 minus f of n minus 3, only 1, where it is 2 now, it is just 1, so 1 will remain. So plus f of n minus 3, f of n minus 3, okay. This is done, okay. And this 2 into f n minus 4, it is going to cancel out with this one, okay. Same way all other will cancel out, right? So this is your final equation, and here you can also write it like this now, f of n is equal to uh, here, this will go here, okay. So 2 into f of n minus 1 plus f of n minus 3, and this is your final formula which you need to use, okay. So this is the pattern actually, right? So here you can say that dp of n value is going to be nothing but 2 into dp of n minus 1 plus dp of n minus 3, that's it, okay. So this is your formula which you need to use to solve this problem, okay. That's it, okay. So this is how this formula is coming up, okay, all this maths. So here, quick recap, let's do, okay. So here first we calculate this, okay, n minus 1, and here this one, okay. So in this part there is just one way, okay. So we can write it like this, f of n minus 1 into 1, okay. These are the total ways, okay, using n minus 1, okay. If we use until n minus 1, and in that we add other ways, right? So like this is total, we have to form, let's say 4 into 2, 2 into 4 we have to form, right? So I am saying that if we know these many ways, then using this many ways, how many these, okay. But there is also one possibility now, maybe we can use this until here, and then we have to find out the ways here, then we have to, this is also one combination, no? Then there is also one combination if I just fix this here and use this many here, right? So all the ways we have to find out, right? So like for n is equal to 4, in n is equal to 3, how many one more cell we are adding like this, okay? So in how many ways we can use this only to get the 4, okay? So that's what we need to do, okay? So that's why we have derived this formula, okay? This is the final formula, okay? So let's write the code. So first, since here in the problem statement it is given that the answer may be very large, so we have to return it modulo 10 to the power 9 plus 7, okay? So here just create one variable int mod is equal to 1 1 2 3 4 5 6 7 8 9, okay? So mode value, and here a few things that we already know, that if our n value is equal to 1, then in that case you have to simply return 1, okay? And also if your n value is equal to 2, then you have to just simply return nothing but 2, okay? And also here create one dp, okay, long dp, and here just give new long here n plus 1, all right? And here you already know that dp of 0 value is 1, okay? And here dp of 1 value, you already know that it is nothing but 1 only, okay? There is only one way to place 2 into 1 tile, okay? And dp of 2, dp of 2 is equal to 2. There are only two ways to place 2 into 2 tiles, okay? 2 into 2 tiles that we have already checked somewhere here, okay? There are only two ways, and there's for 0 area, right? 2 into 0, there's no way, right? So only one, that is only case, one possible case, okay? No place, no tile, right? So there is only one way for dp of 0, right? That's why. And here for int I is equal to 3, I is less than equal to n, I plus plus, all right? So here inside this you have to calculate what dp of I. So dp of I, how you are going to calculate? So you are going to calculate it like this: 2 into dp of I minus 1, okay? We have already derived this formula, and here just do mod here, okay? mod, right? And here once this is done, then after that here use plus symbol, and here dp of I minus 3, and here you have to use mod. That's it, that's it, okay? Mod with mod value, right? And now in the end you have to just simply return the answer, okay? Return here int, and here dp of n, okay? That's it. So that's what you need to return, okay? dp of n value. So now let's run it and see if the any code issues. We'll try to fix that. So the test case has been accepted. Now let's submit it. So see, our solution is accepted, right? So I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you in the next video. Thank you. Bye bye.